Okay, Ross. For lesson 5.3 supplementary video, we're going to talk a little bit about compound angle formulas and double angle formulas, but I think more importantly, we're going to talk about when we shouldn't use them. On the tops of quizzes and tests and culminating, students will be given the sine, cosine, tangent, sum formulas. They can then quickly develop double angle formulas. And the problem is, just like with any other tool, like let's say the factor theorem, as soon as students know that tool, they tend to default to use that tool. I see the same thing happen in grade 10 with students. As soon as they learn the sine law, they start using it in right angle triangles, which is a pretty inefficient tool to use. So let's just take a look at a couple of examples. If I ask you to solve when is the cosine of 2 theta equal to 1/4, this is a question that we should be able to, or let's say, for principal angles. To the nearest degree. No, sorry, to the nearest radian. 100th. This is a question we should be able to do without compound angle formulas. So we should just do it without compound angle formulas. Let's first start with what we should do. If we treat this as sort of like a generic equation, maybe using an onion analogy, we can isolate our unknown by undoing operations in a reverse bed mass order. Oh, I do need to change, the directions here because we're not quite ready for this question for, let's say, a principal angle to nearest hundredth. Right. Yeah, I undo the cosine of with an inverse cosine. Inverse cosine of 1/4. And then I undo the multiplication of 2 with a division by 2. So I get 1/2 times the inverse cosine, theta equals 1/2 times the inverse cosine of 1/4. And my calculator can give me a solution to this equation pretty quickly. Inverse cosine of 1/4, and I divide by 2, and I should have made sure I was in radian mode first, but yeah, I get about 0.66 radians. Okay, that is one solution. We'll talk later in our unit about how this equation actually has 4 principal solutions. So compare that to what students might do if they just feel the temptation to use an identity. If they had, for example, started with this and then they write it as, oh, I see a cosine double angle formula, so I should use the double angle formula and write that as the cosine of theta minus the sine of theta squared is equal to 1/4. Well, now we're in trouble because we have 2 different ratios. Solving an equation with 2 different ratios in the same factor is quite difficult. Often what happens here, though, is that a student won't give up on a bad idea. They just keep on trying to do something. Maybe they factor the right-hand side and try to set the right-hand, or factor the left side, try to set the right side equal to 0. Pretend then that when they subtract both sides by 1, they still have it set equal to 0. No, I'm just not sure what to do from here. Actually, in fact, if you give me this equation, I would probably go back and write it like that so that I could solve. Or maybe I would try to write everything in terms of 1 trig ratio and recognize that I could have used the Pythagorean to get to this formula here. And then sometimes students are pretty proud of themselves when they say, all right, I've got this figured out. Now I can just, I am going to, here, let's write the cosine of theta squared as the square of the cosine of theta so that we can really see the onion here. And we're all set. We can undo these operations in a reverse bed mass order. But why didn't we just do that in the first place? Let's show that this will give us, I'm pretty sure it will give us the same solution. It might give us one of the other 2, or 4 though, other 3 though. If I add 1 to both sides, I guess I'd have 2 times the cosine of theta squared is equal to 5/4. I divide both sides by 2 or multiply both sides by 1/2. I get the cosine of theta squared is going to be 5/8. Here's where undoing an even exponent will get me some of the other solutions that I would have to pay attention to later in this unit. Let's just find a solution and say then that one solution would be the cosine of theta is going to be the square root of 5/8. So theta is going to be the inverse cosine of the square root of 5/8. And I wonder what happens if I type this in. Inverse cosine of the square root of 5 divided by 8. Hey, look at that. 0.66 radians. Okay. This was not a good idea. It was not a better approach. Okay, there was no need to get rid of a double angle. I've even tried making a question like this a little bit more obvious, that you shouldn't be using a compound angle formula, by making this a triple angle. And then I had students that developed the triple angle formula that you're going to see in your homework. It's just not worth it. Ask yourself, why are you using a compound angle formula before you use it? Okay. Let's do another example. Same directions. Let's find a principal angle solution to, how about cosine of theta minus pi by 6 equals 1/3. So best approach is saying, oh, look, I'm trying to solve an equation, so I'm going to undo operations in a reverse bedmass order. I'm going to take the inverse cosine of both sides, inverse cosine of 1/3, and then I'll have theta is the inverse cosine of 1/3 plus pi by 6. And I can approximate this entire thing in one calculator operation. Cos inverse of 1/3 plus pi divided by 6. Theta is about 1.75, and we're done. Versus if we say, oh, look, pi by 6 is a special angle, so maybe I should use a cosine difference formula here. So the cosine of theta minus pi by 6 is the cosine of theta times the cosine of pi by 6 plus the sine of theta times the sine of pi by 6. And we feel like we're on a good, like on a roll here, because I know what the cosine of pi by 6 is. Who cares? Why? Yeah, so I'd have cosine of theta times root 3 over 2 plus the sine of theta times 1/2 equals 1/3. The real problem here is the imbalance between the amount of work that a student puts into a question like this and the number of marks that they get. Because I've done stuff here, and I guess I could maybe multiply both sides by 2 if I really wanted to try to get rid of some of these fractions and write this as root 3 times the cosine of theta plus the sine of theta is going to be 2/3. So look at all of the work that I've put in. And sure, I've demonstrated that I know how to use the cosine difference formula, but in terms of getting a solution to this equation, I'm not closer. I have gone from having one ratio, an equation with one ratio in it, to an equation that has two ratios in it. That's usually a bad idea. The exact same thing happened before. Back here, I went from an equation that had one ratio, which is a desirable situation, to an equation that has two ratios. We could have said, oh, I got rid of two ratios by replacing it with one ratio. So what's the advantage then of getting rid of the 2 on the inside? There might be an answer to that later in the course, but it's not a very big advantage. Okay. Have a look at the homework questions for lesson 5.3 and figure out for yourself when you need these formulas. Because just like any other formula, the quadratic formula, the sine law, the cosine law, the factor theorem, they are advanced tools for advanced situations, and they should not be used when they're not needed, let's say. Okay, try it out.